Welcome back to the Jill and Jason Update. This is week 9 of Combat Vehicle Robotics Engineering Evaluation Test 2. We're sitting up here at yet another beautiful location at Camp Grayling. And you know, Camp Grayling and Michigan have wonderful locations to test robotics.
So one of the hardest parts about robotic testing is being able to communicate to leadership exactly what makes it hard and why it's so important that we take our time and get it right.
Yeah, and you know, we have some really special guests this week that kind of give their perspective of robotics in the Army. And you know, it was their motivation and their persistent ability to communicate that at the higher levels of Army leadership that really got us to where we are today.
So let me take you up to exactly what we're trying to do here in terms of autonomy, robotics, and AI. It's one of the chief concerns of General Murray in terms of how we can fight and change the character of war, and these systems will actually enable us to do that. So if you even go up as high as the Army Modernization Strategy, the 6th priority of a priority research area is autonomy, which is defined as maneuverability and mobility of off-road platforms, i.e. robots, which is why you find us here today out here looking at robots for the engineering evaluation test events that we're doing up here at Camp Grayling, Michigan.
So I'm the transition partner for the Ground Vehicle Systems Center. So our role is to transition the science and technology developed capabilities and technologies to programs of record. And so part of the reason I came up here to evaluate the engineering evaluation test 2 was to work on, to get a sense for the ranges that they're operating at, get a sense for the state of the technology, see how they're conducting the test. Because ultimately, before we transition a technology to the program, to potential programs of record, it needs to be at a TRL level or technology readiness level 6, and see how the MITRE is conducting that independent evaluation.
Testing of autonomous vehicles is not an exact science, it's not a known commodity. It's developing. It's developing on the commercial side, as well as when we take the intricacies of military operation, which takes you off-road with an enemy that gets a vote, and all the challenges that come from not having a structured environment that the commercial industry has, that problem becomes even more complex. While we develop the technology, we have to develop the testing strategy in parallel. And that's really, I think, what's unique about the EET process is we are focused not only on the technology, and really the technology is done by the time it gets to the EET. Now we're focused on how do we best evaluate that technology so that multiple parallel approaches to how you do autonomy, how you do path planning, how you do perception can be evaluated against a common baseline. What the EET is doing for us is allowing us to figure out that testing paradigm to how we evaluate autonomy moving forward.
When we start talking about the software in terms of behaviors, a software-driven process, I like to refer to what I call as the EET testing crucible, otherwise known as Fight Club, Algorithm Fight Club. Because that's what we need to have. We need to have a way to compare, is this path plan or how I get from point A to point B superior to what I already have? I need to do that in a controlled field environment, which is actually hard to do. I can do it in simulation all day, but a simulation is an approximation of the real world with all the challenges that you get in the real world, particularly with sensor noise, with vibrations and everything else. That's why we're doing this sort of EET2 this year. We're validating our data collect architecture in EET2, as well as looking at integrating a variety of components across the enterprise. We have industry bringing in components. We have C5ISR and all our lab partners bringing in components that we're validating through this Fight Club process. So in the end, we can make the autonomy stack and those integrated components better. Once we've done that and validated that it's kind of good at a TRL 6 level, we're going to work with the PEO to provide all the additional requirements that you need to get this software into a program of record.
So one of the things we're looking at is that right mechanism, or what's that right process to transition these capabilities. For the Phase 2 soldier operational experiment, the Ground Vehicle Systems Center is acting as the systems integrator. They're taking on that role of taking a cover capability, which could become part of the robotics technology kernel product line, and they are responsible for integrating that onto the purpose-built RCV prototypes. Longer term, it's still to be determined what that best relationship is, and what it could be is that we have a industry partner that is acting as a systems integrator that will take the robotic technology kernel product line or something similar that has all these autonomous capabilities, and they would be responsible for integrating that on to the platform.
As I look to the future, we're going to be doing more and more complex maneuvers. We're going to be bringing in the AI task force and more of the algorithms out of Army Research Lab to go ahead and compare those as well as with our industry partners and the University Tech Development Division, otherwise known as UTDD, which is comprised right now of University of Texas and Texas A&M. And as they bring more behaviors to the table, in the end, it's all about validating them and moving them along that process so that we can get them into the program of record to deliver the capability that we're shooting for.
Thanks for joining the Jill and Jason Update.
Tune in next week to hear about COAT, another great program from GVSC at the Engineering Evaluation Test 2.